Okay, let's try the last questions here. The first one here, I can see that this is an exterior angle of this cyclic quad, and this angle QPS has to add up to 70 degrees. So that's why x is 30 degrees. There's an exterior angle. This angle up here where P is, the two together have to be 70, so x is 30. Now PQR, there's that angle right there. But angle P, now that we know that that's 30 degrees, these two angles here are interior angles to this exterior angle of the triangle. So if that's 30, then PRQ must be 50 degrees. 50 degrees. Now that's pretty interesting. Maybe there's another way to get at this, but if that's 50 degrees, then Y is 50 degrees because of angles opening up to the same segment, PQ. Now the next one is a proof that takes a little bit subtle. I had done it first and I did it wrong, and I had to redo it because I did a little bit silly. I started off right. I said that PLM is equal to PQR because of corresponding angles and these two lines being parallel. We're given that. We're also given that PQ is equal to QR, and that's important. That means angle Q must equal angle R, because if these sides are equal, it makes the angles equal. Angles opposite equal sides. So Q equals R. So this is the same angle as PQR. Well, if they're both equal, that means that PLM must equal angle R. Oh, and that's an exterior angle. That's the opposite interior angle of this quadrilateral, so it must mean you can put a circle around it. So LMRQ is a cyclic quad because of the converse of the exterior angle of a cyclic quad. If that exterior angle equals that opposite interior one in the quad, LMRQ must be a cyclic quadrilateral. Let's try the next question. I think we've got time to do it. Write down with reasons two cyclic quadrilaterals. Well, hey, that's 90. That's 90. It adds up to 180. MDCE must be a cyclic quadrilateral because of opposite angles in a cyclic quad. You have to write converse of the opposite angles in a cyclic quad. So MDCE is a cyclic quad. Where's another one? Well, if that's 90 degrees, isn't it 90 degrees on the other side? I think it is. ADB and AEB, they're 90 degrees because of angles in a straight line. They must be 90. And then, hey, now we've got two angles opening up to this segment of AB that are equal. If the angles are equal, then you must be able to put a circle around A, B, E, D. It's a cyclic quad, the converse of angles in the same segment. Remember, you've got three ways to prove that you've got a cyclic quad. Opposite angles, exterior angle, and angles in the same segment. And they're all pretty good. This one comes up a lot, angles in the same segment. There you go.